In this lesson, we'll be looking at angle pairs. Okay, what we're going to learn about? We're going to learn about a couple of different types of pairs of angles. There's vertical angles and linear pairs. And we'll do some different things with them. We'll use their properties and set up algebra problems. We're also going to identify complementary angles and supplementary angles. We'll also do problems where we apply those also. What are these used for? There are a lot of things in life and things in nature that have angles. And so some of the examples are when you look at a bridge, cables on a bridge will sometimes make angles. Baseball field, sometimes there's all kinds of angles between bases and the pitcher's mound and all kinds of different angles. So in sports there are angles, but even in nature there's a lot of different things that have angles. The first type of angle we're going to look at are called vertical angles. And vertical angles are angles that, if you have two lines that intersect or cross, the vertical angles are the angles that are across from each other. So another way of thinking it is wherever there's an x, the angles that are across from each other, like angle 1 and angle 2 in this picture, would be called vertical angles. If you look down below, it says that these angles, angle 1 and angle 2, are congruent. I want to point out one other quick thing though. Another way of talking about the situation here is you could say that the measure of angle 1 equals the measure of angle 2. These two statements are both saying the same thing in two different ways. Now we've seen this congruent statement before, congruent, or this congruent symbol when you have an equal sign with a squiggly line above it. So angles are congruent and segments are sometimes congruent. The difference is, on the other one we're using an equal sign. And the reason we use an equal sign is because when we have the m in front of angle 1 and angle 2, that means those are the measurements of them. And so those are actually numbers, like 50 degrees and 50 degrees. So numbers are equal, and things, like segments and angles, are congruent. So sometimes it's hard to make the distinguish between them and to write them correctly. But try to remember that things like angles and segments are congruent. If you have the measure of something, those are numbers, and numbers are equal. Okay, a different type of angles that we'll look at are called linear pairs. And linear pairs are two angles that, well, the definition you can see is the non-common sides are opposite rays. They're adjacent angles, and adjacent means that they share a side. So you can see in this picture that angle 1 and angle 3, I'll show you here, angle 1 and angle 3, they share this side. So they're adjacent, they're next to each other and they share a side. They don't overlap. And then together they add up to 180 degrees. So angle 1 and angle 3 are a linear pair. Angle 1 and angle 2 are also a linear pair. Angle 2 and angle 4 are a linear pair. And angle 3 and angle 4 are a linear pair. We also have angle 1 and angle 4 are vertical angles, and angle 3 and angle 2 are also vertical angles. So we have a lot of these types of angles in this picture. Okay, a few questions to make sure you understand. Are angle 1 and angle 2 a linear pair? Okay, so if we find angle 1 and angle 2, you can see that they are next to each other. They're adjacent. They have a shared side. And this side right here is shared. And they add up to 180 degrees. So the answer would be yes. Are angle 4 and angle 5 a linear pair? Well, not quite. They are adjacent. They're next to each other. But you can see that together they don't quite add up to 180 degrees. So that would be no. Are angle 5 and angle 3 vertical angles? So here's angle 3 and here's angle 5. They're sort of across from each other, but it's not an X. It's really more of a K. So they are not. If this, both sides would have to make an X. So it just doesn't quite in this case. It's more of a K than an X. So that would be no. They're not vertical angles. Are angle 1 and angle 3 vertical angles? Definitely. Okay, you can see that they're across from each other and there's an X. So angle 1 and angle 3, yes, they are vertical angles. Solve for x. So this is, again, a challenging type of problem. We had it on our last test. And what you have to think about is where those algebra expressions are. In this case, they're talking about that's how many degrees the angle that they're sitting in. That's how many degrees those are. So you have to think about the relationship between those two angles. And you can see these two angles where these algebra expressions are sitting, they are a linear pair. And so those two angles add up to 180. So down below here, where we have the algebra equation that we set up, you can see we set it up 4x plus 15 plus 5x plus 30 equals 180. So because the two angles add to 180, that's why we set up the algebra expression that way. So if you wanted to solve that, I'll solve it real quick. Remember the 4x and 5x are on the same side of the equal sign. So we're going to put those together. They're like terms. So we'll say 9x plus 45, because the 30 and 15, equals 180. Then if I subtract 45, I'll have 9x equals 135. And then I'll divide by 9. And then you might have to get a calculator to do that, but x would equal 15, I believe. 9 times 15 is 135. Okay, so that's how you do those. Again, you have to look at where the angles are and decide how they relate to each other. Are they equal? Do they add to 180? So here's one with vertical angles. So take a look here at where those angles are located. They're across from each other, and those are vertical angles, and vertical angles are equal to each other. So when we set up our algebra problem, we're going to say 6x plus 15 equals 3x minus 12. So to solve that problem, I'm going to move this 3x that's on the right side, and so I'm going to subtract 3x from both sides, and then I'll have 3x plus 15 equals negative 12. Then it's just a simple two-step algebra problem. If I subtract 15 from both sides, I'm going to have 3x equals negative 27. And if I divide by 3, I get x equals negative 9. Now in this case, this doesn't make much sense because if I plugged in negative 9, I'd have negative angles up here. So this isn't a great problem for an example, but this is what you come up with for the answer. If I plugged it in, I'd have negative 39, and I'd have negative 39. So it's kind of sort of a weird example, but that's how you set it up, and that's how you would solve it. Complementary angles. Complementary angles are two angles that add up to 90 degrees. They don't have to be right next to each other. They can be drawn separately, like they are on the picture on the right. They can be next to each other, adjacent, like the 80 and the 10 on the left side. Or they can even be, like the picture on the bottom, they can be vertical angles. Any two angles that add up to 90 degrees are called complementary angles. Okay, here's a problem with complementary angles. Find the measure of angle A and the measure of angle B. So remember, the definition of complementary means that they add to 90. So 5x plus 8 plus x plus 4 equals 90. So if I put the like terms together, because the 5x and the x are on the same side of the equal sign, I get 6x, and then the 8 and the 4, I get plus 12 equals 90. Now I have a pretty simple two-step problem. If I subtract 12, I get 6x equals 78. And then if I divide each side by 6, I get x equals, I believe that would come out to 13. X equals 13. But now I'm not done yet, because the question was find the measure of angle A and the measure of angle B. So the measure of angle A, I would have to plug that 13 into the equation 5x plus 8. So 5 times 13 plus 8, that would be 65 plus 8. So that would equal 73. And the measure of angle B would be 13 plus 4, which is 17. So A would be 73 and B would be 17. So you can see they add up to 90. Okay, supplementary angles. Supplementary angles are two angles that add up to 180 degrees. And so again, they can be next to each other, but they don't have to be. They can be in the same picture. They can be two separate angles, like these two 90-degree ones that are off to the right. They can be a linear pair, okay, but so a linear pair is always supplementary because they always add to 180. They could be this 120 and this 60, even though they're not touching each other, they're still considered supplementary. Or these two vertical angles. The little box, that's a symbol that means 90 degrees. So these vertical angles are both 90 degrees. So those angles with the boxes, those would be considered supplementary angles. Okay, last thing, we have one more problem, and that's similar to the one we did with the complementary angles. It says A and B are supplementary. Find the measure of angle A and the measure of angle B. So again, supplementary means that they add to 180. So when I set up my algebra problem, I'm going to have them add to 180. 12x plus 1 plus x plus 10 equals 180. If I put the like terms together, I get 13x, and the 1 and the 10 makes plus 11 equals 180. Now I've got a simple two-step algebra problem. If I subtract 11, I'll have 13x equals 169, and then if I divide by 13, I end up with x equals 13, because 13 times 13 is 169. So I'm not quite done yet, because now I'm going to take that 13, because remember the question said find the measure of angle A and find the measure of angle B. I'm going to plug that 13 into the formula for the measure of angle A. 12 times 13 plus 1. 12 times 13, you might have to get your calculator out, but that adds up to 156. And 156 plus 1 equals 157. Now hopefully angle B is going to add up to 23 because they have to add to 180. And so if I plug that in, I get 13 plus 10, and sure enough, it adds up to 23. So it seems to work because 157 and 23 add to 180, so they are supplementary. Okay, so hopefully that you'll understand all that. If you have any questions, be sure to ask one of your teachers in class.